Hi again, everybody. I'm going to show you in this video how to use the sigma notation to kind of get yourself set up. If you watched the main idea video, you saw that we need to add up a bunch of rectangles easily because we don't want to have to calculate all this stuff by hand. 5 rectangles from 0 to 5 isn't such a big deal, but 206 rectangles is not exactly how I want to spend my Wednesday evenings. So let's just look at this sort of, from a generic standpoint. Suppose we're starting at, A and we're going all the way to B. Yeah, this example is 0 to 5, that's fine. But just from A to B, and our first x is, x sub 1, x sub 2, x sub 3, dot, 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 all the way to the last one. We'll call it n for n number of rectangles. Okay, so whatever, 10 or 11 rectangles, whatever we got, it doesn't matter. N is our last rectangle. I want to focus my eyes on, let's say, this guy right here, this rectangle right here. I want to focus on just finding the area of that one rectangle. Okay? Well, area of this entire region is approximately the area of that rectangle. Okay, it's not a very good approximation, but it's somewhere to start. So that's one rectangle. Let's call this x sub I. So I'm going to call that sort of my ith rectangle, right? First, second, third, fourth, dot, 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 ith, I plus 1, I plus 2, whatever, dot, 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 to my nth rectangle. So just focus on my ith rectangle, and we know that it's just base times height. Let's focus in on what the base is. Okay? Now, in our example, when we did 5 rectangles, the base was just 1. Here, I could actually calculate it out. If I really want 11 rectangles, I could figure that out. I could just figure out how much space I have here, which is 5, and break that up 11 different ways. Or 11 of the same way. So 5 divided by 11, but that's no fun. So in general, we would say that it's b minus a, which is your area to play with here from A to B, divided by the number of rectangles you have. Okay? Again, I know in this example we could calculate it out, but try to think generically. In general, we're going from A to B, and we're splitting it up n number of times. That's how you get each base. And we're going to call that delta x. That's essentially the change in x, right? I have, I have a delta x here. I have a delta x here. Delta x. It's essentially the change in x, right? Delta x all the way to my ith rectangle. I still have delta x. These are all delta x's. That represents the distance between each pair of x values. That represent the base of my rectangle. Okay? So that's my base. What about my height? Well, my height is simply whatever the value of my function is at my endpoint, right? I have all these values for all these rectangles. I have, x sub 1 here, and I plug it in, and I get whatever that is on the curve. It's hard to see there. Let's go here. I have x sub, say 5 here. I come up here, and that's my value for this rectangle. That's my height. Well, what about for my ith rectangle, right? My height is hiding right here for my ith rectangle. Well, if x sub I is the x value, then my height is going to be whatever my function is at x sub I. My function is here. Oops. My function is here, x squared. So in this example, it would be x sub I squared. But in general, let's just generalize it again. It's going to be f of x sub I. Okay? So my area is currently, my approximation for one rectangle is base times height. Okay? That is the most basic version for the the most basic approximation for the area of this rectangle. Okay? Okay, so that's the basic idea to get the one rectangle. Now, in order for me to expand this out to add up a bunch of rectangles, we need to sort of take a step back for a second. So here is our same formula. Area is, base times height. Base times height. And let me just rewrite this for a moment. I'm actually going to just reverse it. Oops. Okay, it's still base times height of the one rectangle. But we don't want one rectangle. We want a lot of rectangles. So I want to make a better approximation by saying, okay, I'm going to use the sigma notation from my first rectangle all the way to my nth rectangle. of my base times height equation. Okay? If I just do the first rectangle, not the first, excuse me, if I just do the ith rectangle, well, that's not a very good approximation, right? If I just look at it as my ith rectangle, that's just this. But I want my first rectangle, my second rectangle, third, fourth, fifth, all the way through n. Okay? This will allow me to do that. This will say, okay, start with the first rectangle. Sigma notation says, okay, take that one and add it to when I is 2. When I is 2, I have my second rectangle. When I is 3, I have my third, all the way to n. Okay? So my ith rectangle is now being spread out among the entire course of the curve, of under the curve. That takes care of all my rectangles. Okay? So this represents an approximation using as many rectangles as we want. If we want 20 rectangles, we would do it 20 times. Okay, now again, I'm still trying to avoid having to do all the calculations, but this at least allows me to summarize what I'm trying to do. So that is another approximation. And then the key question, of course, is, well, how many rectangles do we really want, right? How many rectangles do we really, really want? Well, you know what? I'm guessing you're sort of getting the hang of it now. We kind of want 277, right? No, we want infinite. So let's go back and just look at this thing and say, you know what? If I could just take n going to infinity, I could actually get exactly what that area is going to be. So my area now becomes exactly the limit as n goes to infinity of the sum from my first rectangle to my last rectangle of base times height. Well, obviously that's base and that's height, but still it's base times height. This is also called an integral. If you go from a to b for f of x, which is your f of x here, times instead of delta x we put dx, we call that the integral. And this is called a definite integral because it has a limit. It has actual from a to b. You could actually do these without a to b, but for right now, don't worry about it. This is the area under a curve for right now of what we know how to do for using an infinite amount of rectangles. Okay? I'm going to show you some examples in the next video. Let me know if you have any questions, and I will talk to you soon. Bye.